All right. The focal bar color on this page is really the green one, and it shows that I started off. I actually was a language designer and a compiler writer in the first couple of years of my career. I worked for a company that made microprocessors for satellites, and then I went and got a business degree. Went to work at Oracle and became really a person that was on the road 35 weeks a year. That's the red bar. And right around 1993, you can see that I became a manager at Oracle, and my management responsibilities grew until I left Oracle in 1999. And then this new gold color kind of took over a large portion of my life. But the whole duration, you can see the consistency of the blue bits, which represent me in front of groups of people teaching. And really, I've become more of a software developer again in the last 6 or 7 years. And as a performance optimization specialist, which is really what the one-line tagline that I put to my career, development is where you can make the biggest difference. And that's really the focus of the talk today. So the talk today, I hope that there are a whole bunch of DBAs in the audience too, but what we're going to talk about today is really in the domain of what developers can do to make performance better. I'm going to skip over the contact slide because I know we'll do that later in the event towards the end. So what I want to talk about to begin with is the notion of performance as a feature in and of itself. I think most people that design applications, whether they're database applications or applications that have nothing whatsoever to do with the database, they think of performance really as an attribute of other features. You know, a feature is a thing that has to do with a result that has correctness. But speed is just considered to be sort of another attribute of a feature. Like, for example, I want to be able to insert a name into an address book. Well, the speed of that is often left unspecified, and it's just assumed that it needs to be fast enough and that everybody kind of knows what fast enough is. But rarely do people actually specify performance as a feature in and of itself. And I'd like to give you an example of several questions that really are what I mean by performance as a feature. So for example, how many operational managers, how many owners of systems do you think can answer this question? How many orders did you book between 10 and 11 a.m. on November 4th? Well, compared to the questions I'm going to ask you on the remainder of this page, this one's relatively easy. But the way that most people would answer this question is to go into the order entry lines table and just count. And maybe there's a date stamp in the order entry lines table that says when the order was booked. In fact, there almost definitely would be. And so it would be a simple query to figure out how many orders got booked between 10 a.m. and 11 a.m. on November 4th. That's kind of a rudimentary performance question, really, if you think about it. Now we get to something that most people probably can't answer. What percentage of the times that people clicked the OE book button, what percentage of the times that button's been clicked have the results been delivered in less than 1 second since that index we created on August 17th? Now, we may have other timescope queries like yesterday or between 10 and 11 on November 4th, but there's probably the need to be able to count how many times did somebody click and get a fast answer as opposed to how many times did somebody click and get a slow answer. Most people cannot answer this question any way other than subjectively. By that I mean, well, nobody complained, so I assume it's fast enough. Or Nancy complained, but nobody else did, so I assume that probably only Nancy has a problem and nobody else does. Nowhere in there is the ability to measure, though, whether maybe Nancy's expectations are just more stringent than other people. So it's if you can't answer this question objectively, then you're left either with nothing or with subjective guessing. Here's one. Is there a user or location in particular that experiences good or bad response times? Is it possible that every time somebody does something in Detroit, Michigan, it's slow, but every time somebody does something in Phuket, Thailand, it's fast? Well, again, you either know or you have to guess. Which tasks have the most execution response time variance? Now, when I say task, I mean things like a button that you click or a report that you run. Most systems have hundreds, if not thousands, of tasks that are automated and that run inside the system. But typically, a business has to rely on a handful, maybe 10, which make up the core backbone of that business's data processing. For example, if you're a company that sells things for a living then you need to be able to take orders, you need to be able to pick orders, you need to be able to ship orders, and you need to be able to invoice for orders. And if any of those 4 tasks performs poorly, then you're putting your business at jeopardy. So understanding which tasks sometimes run really fast, but sometimes run really, really slow, that's almost always a reliable indication that you've got some sort of a performance problem that is probably not going to be that terribly difficult to fix. Robin Sands has written some good papers on that subject of just how merely checking for variance in response time is a fairly reliable indicator in performance problems. How about this one? What is your best hour of OE book throughput since January 1st? What's your worst hour? The next question is, during the worst throughput hour, maybe there was an hour where you needed to book 1,000 orders, but you were only able to book 600 orders because your system constraints prohibited you from getting the extra 400 in that you needed. Well, what tasks were competing against OE book during that worst throughput hour? Was there a backup going on? Were there several print label programs going on at the same time? Either you can know or you can guess. Here's one that really is a performance service level objective statement that makes sense to use in an IT department. We've promised that 99% of OE book clicks have to return in less than 1 second, and that 99.99% have to run in less than 5 seconds. Well, do they? Again, you probably wouldn't even consider making a promise like this unless you had your application instrumented in such a way that it was possible to measure objectively whether you're meeting the objective that you've published to your users. When will your 99th percentile OE book response time exceed your 1 second tolerance? For example, imagine that in January of last year or of this year, your OE book response time was 0.3 seconds, but in February it grew to 0.4 seconds, and in March it grew to 0.5, and in April it grew to 0.6. Well, it doesn't take a statistician to realize that if it's degrading by 1/10 of a second per month, your 1 second tolerance is going to get violated roughly 10 months into the, well, actually since it started at 0.4, roughly 6 months after January. So sometime around June or July, if we haven't fixed the problem, then we're going to begin violating the expectation that 99% of OE book clicks will run in less than a second. So these trends exist in your application whether you're aware of them or not. Today's topic is going to be how do we instrument our application so that we can see it. Finally, one person's OE book ran in 1 second. Another person's OE book ran in 10 seconds. Why? How is it possible that that could happen? And this is something that you should be able to know, but it's very, very difficult, I would argue impossible in some cases, using the instrumentation that comes standard with the database product, for example, to know the difference between this user's experience and that user's experience, because for the most part, the $V data just sort of aggregates all these things up into a big bundle. So my whole point today is that every one of these questions is answerable objectively. You can know the answer, but it takes work. It doesn't just come automatically with a product. And that's when I go back to performance being a feature, this is what I mean by performance as a feature. You have to do the work. You have to design the feature. You have to code it. You have to test it. You have to buy hardware for it in some cases. In order to have an extra feature in your application, you're accustomed to saying, well, if I want to run this report 50 times a day, then I need a slightly bigger box to handle that load. Well, if you want performance as a feature, you may have to buy a slightly bigger box to handle the load for the things that your performance feature requires. And then finally, you have to manage it. Now, those of you on the call who are thinking about leaving because you don't have an application that you have control of the source code, you have an application that's prepackaged that you purchase from a vendor, we have the same options. You have a few fewer options, but you still have most of the options available to the other guys. But it still takes work. You have to trust that your vendor did it right or convince your vendor to measure these things. Or you have to retrofit your vendor software, which is possible with triggers, for example. There's lots we can do with other people's software in Oracle to make it behave the way we want it to behave. And you still have to buy hardware for it. You still have to manage performance. Just because you have this data available to you, that means that now you can act with information, but you still have to act. So that's what I mean by performance as a feature. Now on to how do we measure performance? How do we get where we want to go? And I'll start with a quick little quiz. Imagine that I told you that your system CPU utilization is 96%. And this is the kind of information that a lot of DBAs measure, a lot of system administrators measure. Now let me ask you, is that good performance or is that bad performance? And hopefully most of you in TV land right now are looking at this question and thinking, well, there is no right answer. If you're convinced utterly that there is a right answer on this page, then I hope to unconvince you of that on the next couple of pages. Here are two potential answers. One is maybe 96% is just great. It means the system is busy doing work. I mean, after all, we bought a huge system because we want the huge system to do tons and tons of work. If the response times are fine and my utilization happens to be 96%, then hooray. That means I'm only wasting 4% of my capacity right now in idle time. But it's also possible that it's not good performance. Maybe, for example, I have a transaction processing system that are doing a lot of parallel execution operations. I mean, this is usually the kiss of death for a high concurrency system is you take 1,000 users and you multiply each of their workload by 10 or 16 or 64 by parallelizing everything. And on a system like this, the response times can be absolutely horrible, and the 4% is hardly enough headspace to allow the system to serve randomly arriving requests. So the problem with the metric like your system CPU utilization is 96% is that it can be the result of great performance or it can be the result of horrible performance. There's a cause-effect relationship here that cannot be reversed. Good performance or bad performance can cause this 96% CPU utilization observation, but you cannot go from the bottom of this page up to the top. You can't assume you have good performance because of what your utilization happens to be, and you can't assume you have bad performance because of what your utilization happens to be. And that leads us to what I rather pretentiously call the fundamental theorem of measuring things. And that is, if obviously different experiences yield the same measurements, then you're measuring the wrong thing. And we go back to the prior page. These are obviously different experiences. The green experience and the red experience are completely different, yet they can yield the same measurement. And the fundamental theorem of measuring things says that if two different experiences yield the same measurement, then your measurement's not helping. So here's what I suggest that you should measure instead. And really in my, well, I hate to count, but 23 some odd years of experience in the Oracle performance domain, I've only ever received performance complaints in one of two forms, ultimately. Now, sometimes people say, our utilization is too high, can you fix it? And the answer always begins with, well, is it really utilization you're concerned about? Because I can, for example, reduce your utilization by installing really slow 1981 technology disk drives. That's going to give your CPUs enough time to think between I/O calls that I can drop your CPU utilization in evil ways. But that's really not what you want, is it? What you really want is either for response times to be better or for throughput to be better. And this is what I jokingly refer to as performance complaint form R. R stands for response time. And it goes in this format. My either click or report, called whatever it's called, took some number of hours, minutes, or seconds, and either that's too long. For example, we're on fire and we're going to go out of business on Friday if we can't get this fixed. Or, we're really fine, but we wonder, could we do better? If it's possible to do better, then maybe we can hold off on the next hardware upgrade that we had planned for 6 months from now. Because if we can upgrade hardware in a year and a half instead of in 6 months, we can save all that money and reinvest it into our business in other ways. The other way that I've seen performance complaints couched productively is performance complaint form X, where X stands for throughput. And the format here is I get only so many clicks per hour, per minute, or per second, and either that's not enough, we're on fire, and if we don't get this fixed by Friday, we'll go out of business. Or kind of the preemptive approach. We're doing fine, but we wonder if we can do better. This is the company that's reasonably healthy and is concerned about their efficiency because they want to be more fine-tuned as a business. So performance really boils down to two things. Performance is the relationship of task executions to time, and there are really two relationships that characterize your performance. There's the response time way of looking at the world, which is the time elapsed to execute a given task. And then there's the throughput way of looking at the world, which is the number of task executions that you can complete in a given unit of time. Now, the key to measuring performance is to measure these task executions. And the problem here that causes you to have to do a little bit of work is that the machine cannot know what your tasks are unless you tell it. Here's what I mean by a task. A task is simply a thing that somebody would go home and talk about having done that day at work. A click, a report, a batch job, a part of a batch job, a part of a click, a part of a report. So if you remember back when I showed you the hierarchy of performance is made up of response time and throughput, one word may have slipped by you, but this word executions occurred in all three places on this page. And I want to show you a really simple ERD that relates tasks to executions, and it's this. Each task on your system can have n executions. For example, we booked 3,000 orders yesterday. Well, in that statement, book an order is the task, and 3,000 executions is the number of executions. So an example here of a task table and an execution table is basically the spinal cord of my presentation here. Here you can see that we have 6 tasks with IDs 1 through 6, and each task has a very Oracle-ish name. The Oracle-ishness here is the module and action hierarchy that Oracle allows you to use to name tasks. Now the feature that lets you do this, there's a package in Oracle that's a standard PL/SQL package that's been around since, oh my goodness, since before PL/SQL actually, I think. I don't know if that's possible, but it's been around since at least Oracle version 7, and I believe back in Oracle version 6 days. And it's called DBMS Application Info. And it allows you to assign a module name and an action name to each of the tasks that your system executes. And basically from the application's perspective, a task is just a sequence of code path that executes in response to a user wanting to execute a business task. So here you can see module names like OE and PA, and you can see action names like book and ship and pick and match and correlate and recover. The execution table, you can see, it's a denormalization. There's a task ID, which is a foreign key reference back up to the ID column in the task table. And you can see that each execution has a unique execution ID. And we'll talk about where that comes from in just a couple of minutes. But here you can see on this row that I've got my cursor on that task ID 189672 is an OE book task execution. I can tell by the join to this table up top. It was executed by the user N. Wells at IP address 10.17.21.71. It began on August 21st at 8:14:22.307 in the morning, and that task ended that same morning about 500 milliseconds later. It did not error out, and it did 28 units worth of work. And you can read each of these lines here. Visually, I guess this line here for Z. Muller is interesting because there is no end time yet, but that simply means that at the time we executed this query, that task was in flight and hadn't completed yet. Now here you can see that B. Hamza ran a task on August 21st in the morning at 8:14 that actually errored out with a snapshot too old error. So there's lots of questions that we can answer with just this one page, and I'm going to read to you from the initial questions that I asked at the beginning of the presentation that look like this, but I'm going to leave this slide up because I want you to envision how you would write the SQL to answer each of those questions I asked. So for example, how many orders did you book between 10 and 11 a.m. on November 4th? Well, that's simply a query that looks for ID 1 executions that ended between 10 a.m. and 11 a.m. on November 4th. Now you could argue, should they have ended or begun, or do they need to begin and end within that interval? I would argue you probably want to look where end times are between 10 and 11 a.m. on November 4th, where task ID is equal to 1. What percentage of OE book clicks have run in less than 1 second since August 17th? Well, you know where your August 17th where clause fits into this end column. But what percentage of OE book clicks have run less than 1 second? Well, end minus begin is your response time, and it's simply a count of how many of these rows have end minus begin less than or equal to 1 second. is there a user or location that experiences particularly good or bad response times? If you group by user and look for task ID of whichever task you're interested in, then you can see, does any one user have a particularly bad maximum, or a particularly bad average, or a particularly bad standard deviation, or a particularly bad variance in end minus begin times? You could do the same for IP address. You could do the same for a subset of the IP address. Maybe you just want the first 3 numbers to be your grouping constraint, where the last number is basically everybody that's in a particular network group. You can see whether there are particular groups that have good or bad response times. Which tasks have the most execution response time variance? Well, if we group by task and we calculate the variance in end minus begin, we can answer that question very easily. What was your best hour of OE book throughput since January 1st? Well, it's a tougher query. It's an analytics type query, but we can actually group our response times and our counts by the hour, and we can see which hour did we do the most bookings in, which hour did we do the worst, the smallest number of bookings in. So you can see every one of these questions, and I'm going to go ahead and forward on to it. 99% of OE book clicks have to return in less than 1 second. Do they? Well, it's an easy query if you're given the information in this table. Morton's 1-line OE book ran in 1 second. Nancy's ran in 10. Why? Well, this is the one question on the page that this table cannot answer. We might be able to see that, well, Morton's running on an IP address that tends to get great response times, and Nancy is running on an IP address that tends to get poor response times, but discovering why the response time was 9 seconds different requires more drill down information, and we'll talk about how you get that drill down information in just a minute. At this point, I'm going to pause real quickly and ask either James or Ron, are there any questions that I need to clean up at this point? Okay, I'm getting the I don't think so from Ron. So let's go into talking about how you write the code that allows you to know these things. Now hopefully you're sitting here thinking, well, it's really actually not that hard, because if you think about this table as being your specification, and this really is my performance as a feature specification. If I just want to know these columns, all the development-minded people listening to this presentation out there can probably see fairly quickly how you would go about accomplishing the population of these columns and these rows in this table. But let me show you a couple of ideas you may not have thought of that might make this easier. Here is a PL/SQL procedure called GL posting. And I've left out the code for GL posting. The code to execute the business task goes here in the green area. But what I've done is decorated, in fact, Ron Crisco, who's sitting in the office with me, is the person that decorated this particular GL posting package. And what we're doing is calling a function called begin task from a package called ILO task that allows us to specify a module name and an action name. And then at the end of that task's code path, we're calling a function called end task, which allows us either to set a widget count, which is the number of entries posted, which comes from a variable that we will manipulate and keep up to date inside the code path for the GL posting action. Or we can call end task to set an error number to be whatever the SQL code of the error message is if we hit this exceptions clause. So what we've done is identified a task by name in a very Oracle-ish way, and we have also created the information about what either the count of the amount of work got done is, or the number of the error code that ended the particular task. Now, the code behind this ILO task.begin task and ILO task.end task is really not that magical. In fact, you can go look at it anytime you want by visiting this URL. It's open source free software distributed at sourceforge.net, and it's called ILO. It's the Instrumentation Library for Oracle. So I strongly encourage you to go take a look at this, because whether you use it or not, you can at least benefit from understanding the ideas of how and why we implemented the various features of ILO task. And I'll tell you one little thing just to kind of maybe pique your curiosity. One thing that even developers who use DBMS application info tend to do as a bad habit is they tend to set the module name and the action name at the beginning of their task, but at the end of their task, either here at normal completion or here at the exception handling completion, developers can tend to forget to reset the module in action back to whatever they were before this posting module got called. And when that happens, basically there's no way for your instrumentation or for your measurement devices to know that that GL posting task has ended. So you end up with a lot of what I will call artifact data sitting in your $V tables. You know, you think posting's still running, but actually posting completed 20 minutes ago. It's just that the developer sloppily didn't think to turn the module and action names to something else. Well, inside of ILO task, we actually push the module and action names on a stack. And when we encounter an end task call, we pop the stack. So whatever happened to be on the stack task of a bigger task called month end close, for example, the pop restores the state of that stack back to what was running when geoposting got called. We also do some other things with trace data and things. I think you'll really find it interesting if you go take a look at our source code in the ILO package. Now the next example is more fun for me personally because it just looks harder, but it's a much more difficult problem to try to explain to your Java developers how should they instrument their Oracle application code. And the next page is how I recommend you do it. Now this code is very poorly factored. I think that you would probably want to take all the stuff in the blue and probably factor it into its own method, but I wanted to show you the stuff unrolled so you could see, even though it might look complicated because there's so many pixels, it's really not that difficult to understand what's going on. And there are quite a few tools in the standard Oracle product that most people don't even realize exists. So here's some code in Java. It's a connection pooled application, and this connection con equals this.datasource.getConnection is a standard method that you can call to acquire a connection handle. Here's a standard call that you would use to set up a socket from an application connection that you created previously. The stuff in blue I'm calling the instrumentation of the execution ID, and I'll walk you through it real quickly. Here what you see is the definition of a string variable called IP, which is literally your IP address. So the socket object has methods that give you the IP address. This getInet address is converted to a string and then stored in a string called IP. The uname is the username which we would get from this appcon package or appcon object that we referred to up here. The UUID is a universally unique ID, which is acquired by this random UUID call, which is a standard part of Java. And we're converting it to a string. So now we've got a universally unique ID that we can assign to something, which we'll do here in a moment. And what I'll do now is concatenate these three values, the IP address, the username, and the universally unique ID, separated by spaces, into a string called CID, which is the client's execution ID. Now, the next three lines that begin with the word this is an Oracle setting of attributes called end-to-end client ID index to the CID thing. End-to-end action index is another attribute of the Oracle connection that we're setting to the get act result from this appcon thing. So basically we're setting the end-to-end action index to the action name of this particular task that we're executing. The end-to-end module index is the attribute that you send the Oracle connection to name the module of the task. And then this call here is magic. With the Oracle connection, we're going to use the Oracle set end-to-end metrics call to set the this array, this dot metrics thing, which basically is going to take all the work that we've done up here and prepare the database to know the exact identity of the execution that's getting ready to happen. Now, if you just skip the green stuff, the green shade areas for a minute, and just execute the business task here, then what's going to happen is that the business task will be instrumented with the CID, which contains the IP address, the username, and the universally unique ID for that execution. And I'll show you what this looks like in a minute in the trace data. Now, speaking of trace data, I'll go through the green bit for a moment. Here what we see is that the application connection that we've got hiding in the background here has a tracing intention set for it. And that tracing intention or get tracing intention method might, for example, look in a table or a shared memory segment and decide, is a thing called GL posting supposed to be traced. And maybe it doesn't even trace all GL postings. Maybe it flips a random coin and says, you know, for this particular task called GL posting, if a random coin toss of a number between 0 and 1 results in a number less than 0.05, then go ahead and turn on extended SQL, Oracle SQL tracing. Otherwise, don't turn on tracing. So what that would be is a feature that decides to trace posting processes or posting tasks, but only 5% of the time that they run. So you can see how if you think of performance as a feature, you can make up what you want the feature to act like, and it's just code. A developer writes code to trace only 5% of GL postings. That's fine, and it can look that 5% value up in a table if you want it to. That's part of how you define the feature. So here you can see what we've done is said if the application connection has the tracing intention set to true, then what we're going to do is prepare the statement under this connection, begin method R trace.enable, which might turn on tracing, and end. So it's basically an anonymous PL SQL block that we're executing here, and then execute that statement. So what you can see in the green bit is if we're supposed to be tracing, this turns tracing on. If we were supposed to be tracing, of course down here we turn tracing, down here we turn tracing off, and the code to execute the business task goes here. So it's a bit of a complicated slide, and I don't expect you to remember all of it, but since this thing's recorded, you'll be able to come back to page 26 and see, here's what your Java code literally looks like. And again, all these things can be encapsulated into a single method where you basically specify the module in action, and all the rest of the stuff is calculated for you behind the scenes in a method that can be abstracted out of the developer's day-to-day mindset. So when you do that, what do you get? And basically you get magic. If you trace, you get stuff that it's really difficult to believe if you've never seen it before. Now here's a trace file, and I know it kind of stings your eyes to look at it because there's a lot going on here, but I want to focus your attention first on the blue bit here. The blue bit is a line that Oracle emits when tracing is turned on whenever a client ID is set for a given piece of code path. And here you can see that we've got an IP address, we've got a username, and we've got a universally unique ID. This is the format of that UUID call that we made in Java a couple pages ago. I showed you this random UUID thing. Well, that huge, I think it's a 32-byte number, actually, or a 32-byte string, is actually a universally unique ID that's guaranteed on this system or any other, not to give you the same ID if you call it again. And basically now what we have is knowledge that Ken Farrell at this IP address is executing a task with this unique ID, and it began at this time on 9/16 at 19:14 in the afternoon. The module name was set to OE, and the action name was set to pick. Now the rest of this data here explains where the time went for this OE pick task that was executed as task ID A98, B2, etc. for Ken Farrell. The rest of this is really the subject of that full-day class that I mentioned before called Mastering Oracle Trace Data. If you're interested in what all this stuff means, then it only takes me a day to show you that in that course. The red stuff here is what happened as a result of, and I'm going to page back for you, as a result of this being executed. So you can see begin method R trace enable, and in the trace file you can see the execution of the statement begin method R trace enable. And you can see at the end here the execution of method R trace disable. Now, the SQL trace data takes a little bit of training to understand how to read, or it takes tools to understand how to read it. Now, one of the tools that I mentioned before in the method R tools pack creates output that looks like this. And what I've done here, I want you to focus not on the tool or the trace data, but what this in particular means. What I've done is I've run a grouping across all the trace files in a directory, and I've said show me grouped by module in action which module in action accounts for the longest duration of executed time, of task execution duration in this particular directory. And what it shows is that out of all the files that I had in my directory, 741.5 seconds of time were explained, and 31.3% of that time is explained by OE book module and action combinations. 21.6% of the time was explained by PA match. Now, sometimes this is all you need to see as a business, because if, for example, you thought that your business was consumed or was supposed to be doing OE books, but something bizarre showed up, like somebody's custom report that only this one small sales group is supposed to ever run. But if you saw that show up as your 90th percentile contributor to your response time on your system, basically that's evidence that this huge system that you bought and paid for is spending more time running internal reports than it spends actually booking orders which generate revenue for your company. So sometimes this report is extraordinarily valuable in showing that we're really not using our system in the way that we're supposed to be using it. On the next page, I've grouped by the client ID. So here you can see that one execution that has this nasty looking UUID here, executed by Xavier Phelps at this IP address, took 49.699960 seconds. Now, we could look into what task was executed by Xavier Phelps that resulted in this long duration, but basically what you're seeing here is really long executions. I didn't include the task name, the module and action name in these, but I could very well have said group by client ID concatenated with module and action, and then we can see the name of the module and action that was taking place. But looking at this 49.699960 seconds, I might want to drill into that. And with the trace data, I can do that too. I can say I only want to see Xavier Phelps's UUID of EEC4C, blah, 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 whatever that number was, and show me all the calls that took place, but group by the calls, because I don't want to see 18,585 different rows of SQLnet message from client. I just want to see where this guy spent his time. And here you can see that this guy spent his time on 18,585 network round trips between the database and the client. Now, a lot of classically trained database administrators are taught to believe that SQLnet message from client is information that you never want to see, that you want to throw that away. But here what we're seeing is that Xavier Phelps had a 50-second experience after clicking, and the reason that his thing took 50 seconds instead of 10 seconds is because 40.5 of those seconds were consumed on network round trips between the application and the database. And that's definitely information we need to know. But the $V data and the monitors that you'll see, both from Oracle and all the competing products that compete with Oracle Enterprise Manager, they will reliably throw this information away because they can't know which SQLnet message from client time is inside people's response times as opposed to SQLnet message from client times that are outside people's response times, like, for example, when they stay connected but have a phone call or go use the restroom. Another way we can group the trace data is we can say, well, show me this 40.5, this 40.5 blue number here. I want to see the breakdown of these 18,585 calls. How many of them lasted between 0 and 1 microsecond? And the answer is 3 did. How many lasted between 1 microsecond and 10 microseconds? And the answer is there weren't any. But there were 793 calls that lasted between 10 milliseconds and 100 milliseconds. And that's where 51.5% of your SQLnet message from client time went. So we're getting closer now to being able to discover, do we have a network problem? Do we have code path on the client tier that takes between 10 milliseconds and 100 milliseconds to execute? Because clearly most of our network I/O calls, 13,947 of them, took less than 1 millisecond to execute. So clearly it doesn't look like we have a network problem here. Well, I can drill even further with the trace data. I can explain that 40.5 seconds, which is the same 40.5 seconds that showed up here and the same 40.5 that showed up here. I can explain it by individual call if I want to. I can see that on line 146783 of the trace data is my longest SQLnet message from client call, and it took 220 milliseconds to execute. And I can look in the trace data if I know how to read it and figure out exactly which SQL statement that particular network I/O call was associated with. And from that, if I know my code path at all, I can tell what was the client doing between when the database wrote back the results of the prior database call and the receipt of the next database call. What was the application client tier doing? Because maybe this 220 milliseconds is time that I need to go instrument my Java code and figure out why did something take 0.2 seconds to execute between database calls on the Java side. So I hope I'm capturing your imagination about what kind of stuff you can see that's free for the taking. I mean, all these features that I'm showing you are part of Oracle all the way from Exadata down to the free Oracle XE product. It doesn't require any performance pack or diagnostic pack. Here you can see the answer to the question I asked on the prior page. What SQL ID is associated with this 220 millisecond SQLnet message from client call? And the answer is that all the worst network I/O calls were associated with exactly the same SQL statement. So this means there's one place in our source code in the SQL domain where we can go look and see what's happening between calls to the SQL statement that's taking so long. So it's a very powerful diagnostic capability, and all the information you need is right there in the trace data that I've shown you how to turn on and how to turn off. A couple more things you can do with the trace data is diff profiles. You remember earlier I said Morton's thing runs in 1 second and Nancy's thing runs in 10, and you need to know why? Well, here's how you can tell why. You can look at Morton's profile. Where did Morton's 20, in this case, I know the font's really small, but this says 20. Where did Morton's 20 seconds go? And why did Nancy take 49.6 seconds to do the same exact thing? And you can see a little bit here, even though the font's really small, there are more rows in Nancy's profile than there are in Morton's profile. And down here you can see in really teeny tiny font, there's a cursor pin X, wait on X, a cursor pin S that didn't happen up here at all. There's also SQLnet message from client down here that took 40 seconds, whereas for Morton it only took 16 seconds. So there are all kinds of clues here about what you need to go investigate more deeply in order to find out why Nancy's having a hard time with something that Morton's having not so hard of a time on. Diffing profiles is also useful in answering questions like, does our unit test environment have some of the same characteristics as our integration test environment? For example, if you run something in unit tests and it takes 20 seconds, but as soon as you put it in integration testing it takes 48, well, there's code that doesn't scale under load. If the integration test environment's response times don't look at all like what production response times look like, then your integration test system inadequately models production. And you probably need to make some adjustments to make the integration test environment tougher so that you can find problems earlier. By diffing between production and unit test, this is how developers learn how to write faster, more scalable code. If you write something on your laptop and it takes 10 seconds and you put it on production and it takes 60, you need to know that. You need to know that there's 50 seconds I didn't expect, and you need to study why that happens so that next time you write code you don't make the same mistake that causes the same scalability barrier as the last code you wrote. So this data I want to say important, but it's more than that. It's critically important. It's vital as a feedback mechanism to your software developers to ensure that they're continually learning about how the code they're writing actually behaves in production. Now, I'm getting down to the end. In fact, I'm going to show you what I'm calling the performance feature wish list. And what I wish you would do is take a look at this list, and if you see anything that appears missing, send us a note, info@methodr.com. Probably even better is if you tweet @methodr with no punctuation. So if you send a Twitter message to METHODR, anything that you think should be on this list but isn't. And I'll go quickly through. I mean, basically, I want to be able to make it easy for developers to get trace data, and that's what we wrote ILO for. We don't want developers having to think about the 1,000 lines of ILO code that we wrote. We just want them to use it so they don't have to think about it. I want to be able to trace some percentage of executions of a given task. I don't want to trace every posting. I just want to trace 5%. Well, I've explained to you how you can do that. I want to be able to create profiles from trace files. Well, we've got some code that does that. There are other open source vendors out there that have code that does it as well. It's our job, of course, to do the job so much better that you're willing to actually part with some of your hard-earned money to get more features from us. Aggregate trace files by arbitrary dimensions. I want to be able to group by call name. I want to be able to group by line number. I want to be able to group by file name. I want to be able to group by the execution UUID number. I want to be able to group by IP address. And we can actually do those things now. I want to show profile differences side by side. This is a feature that we don't have in our products yet, but I'm working on it. This is code that I'm writing now. I want to be able to predict when the pth percentile response time exceeds some threshold. It's that example where I said response times 0.4 in January, 0.5 in February, 0.6 in March. It doesn't take that much statistical sophistication to sort of make a reliable prediction of when that response time is going to start violating your expectation. And then finally, I want to be able to report on tasks. Which tasks in my system have excessive variance to mean ratio of R. I'm kind of slipping this in on you. This is Robin Sand's work that I mentioned earlier, but the variance to mean ratio is a normalized variance. For example, if you have a task that normally takes, say its average response time is 1 second, but occasionally it jumps up to really large numbers so that your variance to mean ratio is 5. So your variance is 5, your average response time is 1. That's a task that has a 5 variance to mean ratio. Now maybe you have another task that typically runs for 1 hour, but sometimes it runs for 3 hours. Well, the variance to mean ratio on that one might be 3 to 1, which is not as severe as the 5 to 1 as the shorter task. So instead of saying my variance is 2 hours or 3 hours, you calculate a variance to mean ratio which says there's a 3 to 1 ratio of variance to mean, and that allows you to focus in on which tasks you really ought to be trying to optimize first. So I really wish that you tweet me some more ideas if you have them, because we're continually on the lookout for how can we do a better job of explaining to people what they need to be trying to accomplish. There are a few references here which I hope you'll look into. One is the book that features Ron Crisco's work. I showed you how he instrumented the PL/SQL GL posting module before. A much richer description of that is available in one of the chapters of this Expert PL/SQL Practices book. Robin Sands writes about the variance to mean ratio stuff in the same book as well. So it makes this book a particularly good value for you. If you're interested in Oracle trace data, I hope you'll pick up a copy of the Optimizing Oracle Performance book that Jeff Holt and I wrote about 7 years ago. And here is an old copy of what the cover used to look like. In real small print here it says Mastering Oracle Trace Data. The new cover is a little more attractive, and I'll update the slides later with that. But if you're interested, this is the one-day course that I talked to you about, and if you happen to be in Birmingham for UK or UG, the next instance of this course will be on December the 8th, which is the day following the close of UK OUG. Now I know we've used up the allotted time, but I've got more time. If James is willing to stay on the line, I'm willing to stay here for another 20 minutes or so if you guys have any questions you'd like to answer. And I guess, James, with this, I'll put up this slide in case anybody wants to know how to contact me directly, and you can have the screen back.
Thanks, Cary. I'm actually going to leave the screen with you simply because there are some questions that have come in already, and people may want to go back to some of the, or reference some of the slides and some of the sections of the presentation. So,
very good.
Thank you again for the presentation. It was as interesting as normal. It was fantastic. So let me just open up the questions box. So we have had a few questions that have come in during the presentation, but I urge anybody that has any questions on the presentation, and if you want to ask Cary a question revolving around the topic, please put that into the questions panel on your console now. Okay, so the first question we have is from Jürgen Scholster. Thank you, Jürgen. And this is actually to do with your Mastering Oracle Trace Data course. And Jürgen's asking, are you planning to deliver the course online?
Plan is a word I need to define before I answer that question. I intend to, but it's probably going to be 6 months or so at least before I do. The experience right now is you come to class for a day. It's a 10 a.m. to 4 p.m. event, so it doesn't take a full work day. You get a shirt, you get a book, and we talk for the 6 hours about how to use the software that you actually take home with you from the class. Now, one of the reasons I'm doing it live, I mean, obviously if I did it online, I might get a few more students and I might actually be able to spend more time with my family, but I found it priceless, to quote a Visa commercial. participate in that interaction among class members to basically learn more about what's really going on in the field. So it's kind of an addiction to be in a room with real people as opposed to doing the virtual life thing. And that's why I'm committed to doing the course for at least another 6 months or so before I start doing things like, another question that people ask is, when are you going to sell the book separate from the class? And it's inevitable that we will, but not yet.
Thanks, Cary. So we've got a question here from Alex Moynes. Thank you, Alex. And it's, AppCon is really connection con. Is that right? He's referring to the JDBE page.
Yeah, let's go back to that. My answer there is I might need to go offline with you and get some help from my Java guys to make sure. I know that on this page, the AppCon object that we're talking about here is one thing that I've sort of concealed from view. And it's the one place where some of these concepts of, where do you get the username, where do you get the socket name, gets abstracted. And if I remember correctly, going through this with our Java guys, I don't write Java code actually, but going through it with our Java guys, I think that get username was the harder of the two. There was a get socket. Get username was something that was not just immediately obvious how to do, but with the half hour's worth of work, I think. In fact, I have a note here at the bottom of my page you can't see, but it says, when I studied this with my Java guy, it says AppCon does all the things that socket does plus get a username. So it's simply just an augmentation of the socket object that allows you to get access to the username.
Thanks, Cary. The next question is from Blake Hughes. Thank you, Blake. And he's asked, can this be done in .NET as well?
Oh, absolutely, absolutely. I don't have an example of the code for it, but sure. I mean, you've got an ability to get your internet address. You've got an ability to get the name to which somebody connects to your application that you've written. You've got, I presume, I can't imagine that there's not a random UUID method out there. And then in the database connector that you use to get to the database, what you want to do is find the keystone here is this blue guy, the set end-to-end metrics function. And basically it's a feature that was introduced in Oracle 10G that is in the OCI, the Oracle Call Interface. And as soon as this set end-to-end metrics function was introduced in the Oracle Call Interface, the database connector writers, the JDBC, the ODBC, the Perl database connector, the DBI objects, those things adopted relatively quickly in my experience the ability to call this set end-to-end metrics thing that was a new feature in Oracle 10G and the OCI. Ron, are you actually looking it up to see? Yeah. Ron is sitting in the office next to me. I think he's Googling for the .NET way to do set end-to-end metrics. I'd bet large money that it's there. I don't know what it's called, and if Ron comes up with it here in his Google search, I'll insert it into the recording here in a couple minutes. But the answer is absolutely expect to be able to do this. It's just a matter of finding the function call in the .NET universe that maps to this set end-to-end metrics thing that's here.
Thanks, Cary. I think if we move on to the next question, hopefully Ron can find something in the meantime and we can come back to it.
Good idea.
So there's another question from Jürgen here, and he's asking, are you planning the Oracle Trace Data, Mastering Oracle Trace Data course in Germany?
The agenda right now that's posted at our website has the one UK course coming up. And then I've got a few months that I'm going to be in the U.S. What I'm wanting to do, there's several people in Brussels that are kind of waiting on the edge of their chairs, they tell me, for a schedule for there. We've got friends in Copenhagen. We actually taught the course in Copenhagen a couple months ago. I've got friends in Zurich that I think might be able to help me put a room together. The bottom line is especially for the the Germany, Switzerland, Belgium, kind of the Northern European area. I intend to go there probably in the fall, maybe March, April timeframe. If we can get enough people that are interested, I'll commit to being there sometime in Q2, Q3 of 2012 at the latest. So we don't have plans, but it's the kind of thing that if there's an expression of interest, then I'll find a room. And by the way, it's very helpful if you have ideas about a good venue. For us, the nicest thing is if we can get 4 or 5 people from one company and get their company to agree to let us host it there at their site. We'll exchange a free seat or two for the venue opportunity. But right now, we're really looking for people that are interested, and this thing's on the road, and I'll book it.
Thanks, Cary. That's the last question that we have in the question panel. But please, if you do have something you want to ask, it's obviously a great opportunity to put your questions to Cary and actually get a direct response straight away. Please type them in now, otherwise we will wrap up. Cary, has Ron found anything out? We could go back to Blake's question.
Not yet. He's getting close, he said, but he doesn't have it yet. If you're planning, James, on a follow-up message to folks, this might be something, as soon as we find out, we can mail it to you, and then you can include it in that follow-up.
Absolutely. As always, a full recording will be sent to everybody that has attended, and also to anybody that actually registered for the session. So I think it would be a good idea we can include that link in that follow-up email.
Very good.
Okay, so there are no more questions coming in. I think if we can just go back to the final slide, Cary, where we've got your contact details. If anybody has any questions, please do get in touch with Cary, either through his website, through his blog, or on Twitter.